Alright, so here's a few examples, and in each case we want to find dy over dx. So we want to do this implicitly, so we don't want to actually have to solve for y first. Okay, so that means we're going to treat y as a function of x when we go through and differentiate. So let's see, derivative of x squared is 2x. Derivative of x times y, that's a product rule. So 1 times y plus x times y prime. And then minus y squared, that's going to be minus 2y, that's the derivative of the outside times the inside function times the derivative of the inside function equals 0. Good. Alright, so now if we wanted to solve this for y prime, we could do that. So that's going to be 2x plus y plus, go ahead and factor out that y prime, and then I'll have an x minus 2y, it looks like, equals 0. So bring over the 2x minus 2x plus y over there, divide by x minus 2y. Good. Alright, so something similar happens here that's a parenthesis here. So when I differentiate this, I'm going to use a product rule, and so the derivative of y is going to be our y prime times the cosine of x plus y times the derivative of cosine, which is minus the sine of x. Good. That's equal to derivative of x squared, which is 2x, plus derivative of y squared, 2y, dy over dx. Good. So again, we can bring our y primes together. So I'll bring this over to the other side, and then I can bring this over to that side, and I will have, let's see, y prime is equal to, let's see if I can do this in my head, 2x, then bring that over, plus y sine of x, right, all divided by our cosine of x minus 2y. Good. And so there's your y prime. And now we have our arctan. We just learned that formula. So remember that in your formula table there, if you have the arctan of x, we learned that the derivative was 1 over 1 plus x squared. Okay, and so in this case, if I'm taking the arctan of x squared y, the derivative of that is going to be 1 over 1 plus x squared y squared, but then you're going to multiply by the derivative of this expression. Okay, and then that'll be equal to 1 plus the derivative of xy squared, which would be 1 times y squared plus x times 2y times y prime. Good. So this is going to be a little bit of algebra here, but that's okay. That's 1 over 1 plus, and then that's going to be x to the 4th y squared. And then the derivative of this expression is going to be the derivative of the first function, 2x times y plus x squared times the derivative of y. We'll just write it as y prime here. Good. And then just rewriting this side, we have 1 plus y squared plus, that looks like 2xy times y prime. Good. And I think I will leave this one to you. You would have to multiply this through, right? And then bring all your two y primes together to factor the y prime out, and then you could solve for y prime. Good. All right. I think I will leave it. Oh, we have a couple more. Let me pause for a moment. All right, so let's see if we can work through this one. So we're told that f of x plus x squared times f of x cubed is equal to 10, and we know that f of 1 is equal to 2. So we'd like to be able to find f1 or f prime of 1. Let's see how we would do that. Okay, so we'll go ahead and just differentiate everything. So if we differentiate everything with respect to x, we would have f prime of x plus, now remember this is a product rule, so the derivative of x squared is 2x, and then we just bring down our f of x cubed plus x squared times the derivative of f of x cubed. Remember that's going to be 3 times f of x squared, and then we multiply by the derivative f prime of x. Good. And then that's equal to the derivative of 10, which is 0. Alright, then now if we just plug in 1 for x, right, we would just add x equals 1. We have f prime of 1 plus 2 times 1 times f of 1 cubed plus 1 squared. That's just going to be 1. So 3 times f of 1 squared times f prime of 1 equals 0. And so this is our unknown, the f prime of 1. So let's go ahead and plug in the values everywhere else. That's f prime of 1 plus 2. F of 1 is 2, so that's going to be 2 times 8 plus 3 times 2 squared is 4 times f prime of 1 equals 0. Good. So let's bring the 16 over. Let's see, that's 12 plus 1 is 13. And so it looks like f prime of 1 is equal to 16 over 13. Good. Alright, so this is kind of a flashback to our previous section, right? Where we were looking at expressions of this form and we were differentiating those. Good. Let's see, so how would we differentiate something like xy plus e to the y equals e? Find dy over dx. Okay, so in this case we have a product rule, 1 times y plus x times y prime. And now this is e to the f of x power, right? So the derivative of e to the f of x power is going to be e to the y times y prime. And then the derivative of e is 0 because e is a constant. Very good. And so now you can solve this for y prime, right? So that we have x plus e to the y prime is equal to, I'll bring this y over to the other side, minus y. And so y prime is minus y over x plus e to the y. Good. So there's my formula. All right.